So today, we are diving straight into what is arguably the biggest structural clash in the entire history of decentralized networks. We're talking about the great blockchain trade-off, Ethereum versus Solana. We're basically going under the hood to see which virtual machine actually runs the future of money. And this is such a fascinating matchup right now. Looking at the landscape in 2026, Ethereum's modular, roll-up-centric roadmap and Solana's monolithic, hardware-optimized strategy, they have both fully matured. We aren't just looking at minor software updates here. We're looking at two completely opposite philosophical approaches, both trying to solve the exact same global problem. Absolutely. So to really understand this trade-off, we need to dig into the architecture, the developer experience, the wildly different costs, and ultimately figure out exactly who should be using which network. Well, let's set the stage with just one staggering number, 20,000. That is the transaction cost multiplier between these two platforms.
That is a massive gap. So what does that actually look like in practice for, say, a business or an everyday user?
Right, so on Solana, a simple token transfer or a swap, it costs a fraction of a cent. We're talking roughly $0.00025. But on the Ethereum mainnet, that exact same super simple transfer averages anywhere from 30 cents to $15. And if you're executing complex DeFi interactions during a massive bull market, that can easily spike from $50 to over $500, just depending on network demand.
No way. I mean, that's not just a minor inconvenience.
Exactly. When we talk about platform economics, this 20,000x gap literally dictates whether a specific business model can even survive. Imagine you're running an app processing 100,000 daily transactions. On Ethereum, your users are paying upwards of $1.5 million a month in fees. On Solana, about $750. Over a year, that is $18 million in overhead compared to just $9,000. It is night and day. Which brings us perfectly to the real pain point for the average retail consumer. I mean, are you tired of paying pizza prices just to move your money?
It really is the perfect analogy. In the Ethereum ecosystem, the gas fees for one single basic transaction can literally cost as much as a large pizza. And if you're just trying to send $20 to a friend, or dip a creator $2, or buy a $5 digital collectible, paying a $20 network fee makes absolutely zero economic sense.
Right, it completely kills the idea of microtransactions. It just creates an incredible amount of friction for everyday retail users, which makes consumer adoption on Ethereum's base layer incredibly difficult. Now, Solana's subcent fees, they make those high-frequency microinteractions completely frictionless. But that raises the obvious question, why is there such a massive price difference in the first place? And honestly, it all comes down to the engine. Exactly. The reason for this massive price gap comes down to a core architectural conflict right under the hood. On one side, you have the Ethereum virtual machine, or EVM, which uses sequential execution. And on the other side, you've got the Solana virtual machine, or SVM, utilizing parallel processing.
So the EVM processes transactions one at a time. It's a single-threaded environment. So in plain English, it means the network acts like an older computer that's just using one single processor core to do absolutely everything. Even if two transactions have nothing to do with each other, they still have to wait in the exact same line.
Spot on. Now, Solana, on the other hand, was designed from the ground up by former Qualcomm and Dropbox engineers to actually take advantage of modern multi-core processors. Its architecture is multi-threaded. That means it uses all the available cores in a computer's hardware to process multiple, non-overlapping transactions at the exact same time. The best way to think about Ethereum is like a massive, highly secure global library. Every single time someone wants to check out a book or, execute a smart contract, every single librarian in the building has to agree on exactly who has which book before the next person can even step up to the counter.
Right. And you might wonder, why on earth build it this way? Well, it's actually a feature, not a bug. It is incredibly secure and robust. By forcing everyone into one sequential line, there is literally zero chance of double spending or conflicting records. This is exactly why major institutions trust it with billions of dollars. But it creates a massive bottleneck. If 1,000 people show up to the library at once, the line wraps around the block. Because it's sequential, everyone starts bidding up the price of a fast pass to bribe the librarians to skip the line. And that is exactly why Ethereum's gas fees go through the roof during busy periods.
So on the flip side, Solana counters that bottleneck by operating like a massive fast food line. It really does. Picture a fast food restaurant with 50 cash registers open all at the same time. Now you might be wondering, how does the network know people aren't trying to spend the same money at different registers? Well, that comes down to Solana's C-level runtime. So how exactly does Sea-Level handle that? Think of Sea-Level as a hyper-efficient restaurant manager with a clipboard. It scans all the incoming orders in advance. It realizes, hey, this person in New York is buying a burger, and this totally different person in Tokyo is buying a milkshake. Because those transactions don't overlap or touch the same data, Sea-Level routes them to different processor cores to be executed in parallel. Nobody has to wait for someone else's totally unrelated transaction to finish. It maximizes hardware efficiency to keep the line moving instantly. Now, when we take a snapshot of the 2026 ecosystem, we can see these two different philosophies playing out really clearly in the market. Ethereum is absolutely the heavyweight when it comes to total value locked. We're looking at $55.6 billion compared to Solana's $8 billion. This metric really shows institutional trust. It's the deep liquidity sitting safely in the network. Ethereum also commands the largest developer mindshare with nearly 32,000 active developers building on it.
But when you look at weekly decentralized exchange volume, or DEX volume, the story totally flips. Solana actually pulls ahead here, processing $11.49 billion compared to Ethereum's $7.62 billion. And this is a direct result of those average fees we were just talking about. When a swap costs fractions of a cent on Solana, it naturally attracts high-frequency trading, arbitrage bots, and massive retail volume that simply wouldn't be economical on Ethereum's base layer, where fees are averaging 50 cents to $3.
So, we know Solana is fast and cheap for retail volume, but let's be real, raw speed is totally meaningless if the network is a nightmare to build on. Let's talk about the developer experience.
Right. So if you want to build on Ethereum, you use Solidity. It's an object-oriented, high-level language. It is incredibly popular, relatively easy to pick up if you have a background in JavaScript, and there are just thousands of ready-made, audited templates out there. In Ethereum, the data and the code are tightly coupled together inside the smart contract.
But Solana uses Rust. And that comes with a totally different mental model, right?
Exactly. Rust programs on Solana are what we call stateless. What that means for a developer is that the smart contract code and the user's data are completely separated. The program itself doesn't remember who you are or what your balance is. You actually have to pass that state information into the program every single time you interact with it. It is fantastic for security and lightning-fast parallel processing, but yeah, it definitely comes with a significantly steeper learning curve.
Now, we absolutely cannot talk about Solana without addressing the elephant in the room: historical reliability. In its early days, the network was definitely known for occasionally going offline under heavy load, which obviously gave Ethereum a massive advantage when it came to perceived stability. But that brings us to the massive 2026 game changer, FireDancer.
FireDancer is an absolute engineering marvel. It is a brand new independent validator client for the Solana network. And crucially, it was built completely from scratch in C and C++ by the experts at Jump Crypto.
And C and C++ are the exact same low-level, high-performance languages used by Wall Street firms for traditional high-frequency trading, right?
Precisely. FireDancer is not just a patch or a minor update to the old software. It is a total ground-up rebuild. It's designed to heavily optimize networking throughput and effectively remove the ceiling on what the Solana hardware can handle.
And the introduction of FireDancer achieves something critically important called client diversity. Now, Ethereum has had this for a long time, and Solana now finally has it too. The best way to think about client diversity is like accessing the internet. You can use Firefox or you can use Chrome. They both let you browse the exact same web, but they are built on completely different underlying code bases.
That is the perfect way to visualize it. Before FireDancer, nearly all Solana validators ran on one single client. That meant if that one specific client had a critical bug, the whole network went down. It was a major single point of failure. Now, with the FireDancer client running alongside the original Agave client, a bug in one no longer halts the network. If Agave struggles, FireDancer just keeps happily producing blocks. It completely transforms the reliability of the entire ecosystem.
And the performance upgrade is honestly just as mind-blowing as the reliability upgrade. When you compare real-world transactions per second, you can see Ethereum's base layer is processing about 15 to 30 TPS. Solana's current production throughput handles roughly 1,100 to 5,000 real-world TPS.
But then you look at FireDancer. FireDancer shattered the speed ceiling in live testing, demonstrating over 1 million transactions per second.
Just to put that into perspective for a second, the entire global Visa network handles roughly 24,000 to 65,000 transactions per second, theoretically.
Exactly. Hitting 1 million TPS isn't just an upgrade. It is a total paradigm shift. It creates so much network headroom that Solana can absorb massive global spikes in network load, like an explosive viral token launch or a huge global event, without degrading performance one bit. It literally makes blockchain highly competitive with traditional high-frequency finance.
So bringing this all together, we really arrive at the defining characteristics of each chain in 2026. If we boil it down, Ethereum is the vault and Solana is the trading floor.
That perfectly synthesizes the market reality today. Ethereum is the institutional vault. It is the ultimate store of value for what we call slow money. If you are a sovereign wealth fund or a massive institution managing billions of dollars, and you need that deep liquidity, years of audited history, and maximum settlement assurances, Ethereum is where you park your capital. You don't really care if a transaction takes a few minutes or costs $50 because you're moving $100 million.
Right, but if you want to build a consumer app, a Web3 game, or high-frequency trading protocol where users shouldn't even notice gas fees, you go to the trading floor. Solana is the engine for fast money, high-velocity capital, and seamless user experiences.
And what is truly fascinating is that the industry is finally waking up to the fact that this isn't some zero-sum, winner-take-all game. There's a prevailing sentiment in the industry right now that many of the strongest development teams simply build on both. They treat Ethereum as the settlement and custody layer, and Solana as the execution venue.
It is the ultimate hybrid approach. Instead of all this tribal infighting over which single chain is better, top developers are impartially utilizing both chains for their specific architectural strengths. Use Ethereum for its unmatched security and decentralization to custody the actual assets, and you route your high-speed, low-cost daily user execution through Solana. You really do get the best of both worlds.
So, it ultimately comes down to your specific use case. Are you looking for the deepest liquidity or the fastest throughput? Which brings us to our final question for you watching. Are you Team ETH for that vault-like, bulletproof security? Team Sol for the lightning-fast trading floor speed? Or are you utilizing both to build the next generation of finance? It's a strategic choice every developer, founder, and investor has to make based on their specific goals. We hope this breakdown helped clarify the brilliant engineering happening on both sides of this great blockchain trade-off. Thanks for joining us on this explainer, and we will catch you in the next one.